Okay, so let us try to see what it would mean to have consistency in the Grassmann integration. So we want to define. Sorry, the color is wrong. So ultimately, we want to define a mapping P, which is acting from the Grassmann algebra extended by the identity because possibly some numbers and GL prime. The numbers are in the kernel of that integral, and then otherwise we are mapping between different Grassmann words. And what we would like to have is that this Grassmann integral against P of P is equals to 1, and essentially everything else is 0. So now, for example, what we could say is that we are considering a set of generators G1 until GL, and we are mapping it to some other basis of G1L. So M applied to the vector of those G's, 1 until M G L. So this one is, for example, the summation over K from 1 until L, M1K, GK, and this one would be summation K from 1 until L, MLK, GK again, right? So that's what I mean by MG. So now let's say I want to, so I will be calling those G with a tilde, and this is G1 with a tilde all the way until G tilde L. And what we were saying in the session was that G1 is the span C of those GKs, but it's the same linear space span C GK tilde if M is a matrix which has a non-zero determinant. So now I would like to ask what it means to integrate against this G tilde of some mu. And here I will have, for example, G of nu. So if I would have here tilde, I would have the delta mu nu. But let's say I don't have this agreement, and I have G of, here we had mu, so I will make it mu. G mu, G nu. So here G mu, and here not G mu. So for the case of mu being the generators, so equals to some eta, we understood this, and now the question is what happens in this more complicated case.